Hello again, everyone. Today we're going to talk about 10.2 logarithms. But before we even do that, we're going to start with a couple simple little examples here. The first one is going to be 3 to the x equals 9. And the other one is going to be 2 to the x equals 16. And what I want you to do is just think about what's the answer. What would x have to be to make those two equations true? Well, both of these are fairly simple. 3 to what power is 9? Well, you know that's 2. And 2 to what power is 16? Maybe not quite as easy as the first one, but hopefully you could figure out that that would be 4. 2 to the fourth is 16. Now, my point here is not to just give you some simple exponential equations here, but rather it'd be something more along this lines. 5 to the x equals 20. What does the exponent have to be for 5 to that power to equal 20? Well, that's not quite as easy, because I know that you know that 5 to the first equals 5. I know that you know that 5 to the second equals 25. So that tells us that our answer is somewhere in between 1 and 2. The question is where? And there's an actual answer to this. It's not just a guess, 1.3, 1.4, something like that. But that's what we're going to talk about today is how do I figure out these exponential problems when they're not integers or they're not whole numbers. They're decimal form. And that's what leads us into section 2 today, which is called logarithms. Now we'll talk a little bit more in detail in class about the definition of logarithm, but essentially a logarithm is a fancy way of it's a fancy way for us to figure out those decimal exponents. And there's a rule here that we're going to put up, and that's going to say that b to the a equals r if and only if. It's a good geometry term right there. Log base b of r equals a. And that is when b is greater than 0 and not equal to 1 for r being greater than 0. Now we'll get into great detail about what all this stuff means. This is going to be one of those lessons where we're going to learn how to do it first, and then we're going to learn the whys later. So what I would like to start out with is just switching things. This is called exponential form, and this is called logarithmic form. Logarithmic. And the way you say this is you say log base b of r equals a. Log base b of r equals a is how you say that. So let's start with some switching from form to form here. Let's go with the example I gave you just a minute ago. 3 squared equals 9. If I was going to write that in logarithmic form, the way I would do that is this. I would write log, and then if you're a visual person, what I always visualize is the 3 drops down, and then these two numbers switch. And then I would say that log base 3 of 9 equals 2. These two things are equivalent. They mean the exact same thing. And like I said, I know you don't know what the heck we're doing there, or what the real meaning behind that is, but that's okay. We're going to get there. Let's do this one. Okay, so 10 to the 5th equals 10,000. So you're going to change it to log form. Log, or the 10 drops down, and these two numbers switch. Now you can go backwards as well. Let's go backwards. Let's say I wrote it as log base 9 of 3 equals a half. Okay, how do I write that in exponential form? Well, if when we went from here to here, we dropped this down and switched those, here we're going to raise this up and switch these. So it'll be 9, and then these two switch, 1/2 equals 3. And hopefully that makes sense to you, that 9 to the 1/2 does equal 3. So let's try one more here. So let's say log base 2 of 1/16 equals -4. Okay, so you would raise the 2 up, switch these 2 around, and there we go. So remember, these are equivalent to each other. In order to get them in the correct form, you just got to follow this little pattern here, that from b to the a equals r equals log base b of r equals a. So you simply drop this down and switch those around. Sometimes people also just remember this, that bar equals bra. Bar equals bra. Okay, is another way to kind of remember it. Okay, so let's move on down. We're going to talk about some evaluation stuff. Again, I know we don't understand logs completely. That is fine, but we should be able to, just following the pattern we talked about up above, we should be able to go through and change these log notations into exponential and then be able to solve. So for instance, let's talk about this one right here. Now you notice it just says evaluate, so if it helps you, put equals something, and so we're simply going to change these things into exponential form. So to follow the pattern that we just did right above, I'm going to write this one as 3 to the x equals 81. And then, now if you know that in your head, wonderful. If you don't know it in your head, remember we're going to go through that. We did this before in a couple chapters ago, that I could simply write this as 3 to the x equals 81 is the same thing as 3 to the 4th. Therefore, remember that 3 little triangle dot, you could say x equals 4. So this is saying that log base 3 of 81 equals 4. Okay, not terrible, hopefully. This is a good section here. Once you feel like you kind of got it, it'd be good to kind of pause before I do one of these, and then hit play and see if you got the right answer. So I'm just going to go through and solve these three, and let's see how you did. So the next one, again, if it makes it easier, I would write 2 to the x equals 1/16. Now if you don't know what that is, well, you could write it as 2 to the x equals 1 over 2 to the 4th. 2 to the x equals 2 to the -4, so therefore x has to equal -4. Next one. Put equals x. 1/3 to the x equals 27. This one's a little trickier. Now, what I could do, well, you could do a couple things here, but what I would probably do is this. I would probably move this 3 up, and if I do that, that becomes 3 to the -1 to the x equals, and over here this is 3 to the 3rd. So that's 3 to the -x equals 3 to the 3rd. Therefore, -x equals 3, so x equals -3. It's a tough one right there. One last one, so let's try this one. So it's 8 to the x equals 4. So I can't change 4 to a base of 8, and I can't change 8 to a base of 4, so I would change both of them to a base of 2. So 8 is 2 to the 3rd to the x, and this is 2 squared. So it's 2 to the 3x equals 2 squared. So therefore, 3x equals 2, x equals 2/3, just like that. So hopefully that makes sense for you right there. That's a big part. If you can switch logarithmic into exponential and solve, that's a big part of what we're going to be doing. So let's move on here. Next part, let's go through and solve here. So solving is not much different. The only thing really different is just our location of our x value here. We're still going to go through and do the same first steps, and that being change it to exponential form. So if I did that, so this one would be 4 to the 3 over 2 equals x. And now here, just use your calculator. Type in 4 to the 3 halves. And so hopefully, once you've done that, you realize that x equals 8. Okay, so definitely on these next two, hit pause real quick and try and solve both of these. Alright, so let's see how you did. Let's see, this one would be 7 to the negative 1/2 equals x is how I'd write it. Now obviously it's a negative exponent, so that means I'm going to have to drop this down. And then you're going to end up, if I was going to do this out by hand, I would do it as 1 over 7 to the 1/2 equals x. But you know 1/2 is the same thing as a square root. And you know that you have to rationalize that, and if you rationalize it, you'll end up with this. This is the answer you should be giving me. Do not give me, don't plug this in and give me some decimal approximation. You should always be giving exact values. Remember, exact values means there's no rounding, no decimals like that. So make sure you keep track of that. Make sure you don't just get lazy and hit your calculator and see what the decimal approximation is. Okay, next one. So this would be root 5 to the 4/3 equals x. Now this one's a tough one. So how on earth do I do that? Well, what I would do is, I don't really know what the square root of 5 to the 4/3 is, but I do know that if I change square root of 5 to 1/2, and I do know if I multiply 1/2 times 4/3, I end up getting, let's see, that would end up canceling, so I get 5 to the 2/3. And then if I was going to write this as a radical, I know that I could change that back. This would be the cube root of 5 squared, or 25. Simple as that. And then, as far as we're concerned, if there's a choice between exponential, like 2 to 2/3, or as a radical, write it as a radical. Okay. Now, the last two, or last couple of problems here that we're going to talk about are ones that we're going to do on part 2. So what I'm going to need you to do, this is going to end here in just a moment. I need you to go back and I need you to find the second set of notes. So it'll say 10.2 logarithms part 2. It'll only be about 3-4 minutes, but I need you to find that and watch that. So hopefully this has been pretty good for you. And well, I'll talk to you again in just a moment.